Oh, thank you. And it's really awesome to see how strong the London chapter is, and truly impressive to see OWASP around the world. I gave this talk at AppSec USA a few weeks ago, and this is the speedrun abridged version. But I'm trying to bring back all of I've been in AppSec 15 years, like what I've done throughout the years in blockchain and FinSec and now AI, but trying to bring the best practices back to the community and help make it a little more practical and hands-on. So you can see the main talk where I go through this in a bit more depth. I'm just going to cover the first one, but I cover how to DDoS, what happens if you get malware in your enterprise, how do you go about doing triage against an APT. But this is the speed run where let's begin just with the PII. So you're in an enterprise and your developers have just leaked all of your customers' PII to the internet. You're the security engineer. They come to you and say, this is your time to shine. Jump in there. You've been exposed. Your sensitive data is out there. It is scary. We've all been in a situation where you don't know what you're doing next. Some of the key takeaways: make a ticket. Start documenting this. You're going to need to go back 3 weeks from now when you haven't slept for 2 days and give a full report and accounting. So cut a security ticket, give it a PII date. And this is kind of your beginning of your documentation. And you're going to throw in something like, oh, what has happened? We've leaked the PII. The risk level is high. Who is it impacting? The response priority. And I'm trying to give you, just breathe for a second. This takes 2 minutes, 5 minutes, 10 minutes. And you're looking at a rapid assessment. You're now going to go through the time box of 30 minutes. You're not going to end up in analysis paralysis. Just cut a ticket, start making documentation, have tactical and practical outcomes of what's been hit. All of our user data is out there. Our critical PII. We've understood what critical PII. It's home addresses, critical numbers, account numbers. Legal has been notified and says this is critical. Leadership has eyes on it. And this is not the first time. And maybe you're lucky enough to not be the only security engineer facing this on your team. Maybe someone else is able to pick up the slack and come after you and follow up with your team. You're looking at, how did this happen? What systems got hit? What data? What storage? And this is where you sit down with your team and start understanding what has just happened. So out of the rapid assessment, look at notifications. Who are you sending this to? Legal, management, customers, marketing. And this is where hopefully you've thought ahead months beforehand of, if we have our customer data hitting the internet, what is our legal stance on this? Our marketing, how are they going to message this to our customers? What kind of SLA are we going to have to notify everyone your password has been breached? Please know your account is now shut down on our service, and marketing has a run book for how to respond to this. And these are all the things that you can do now. And I recommend just playing, what do you wish you had done if? So if your critical database ended up on the internet, what do you wish you had done? Maybe your management is a key stakeholder, and you need to be very sensitive about how you communicate this to your VC funding or whatever. That you could think now, what do you wish you had done if your network is compromised and you have intruders in your network? How are we going to notify our customers about our service going down? So, and how to stop this the next time, that's our real job. We're the first responders that get the notification. We processed it, we boxed it, we said, this is the problem. And now what? How do we communicate to our teams that we're fixing this? How do we go about actually remediating this? And this is the SDLC. This, when we talk about threat modeling, what is threat modeling? You're going to sit down with your engineers and they're going to say, well, this has been breached. This is what got hit. It's called Project Maple. We have ML models exposed to the internet. This has Dynamo and SQS, and we have basic authentication. This is Project Maple. And They show you this design document. Hopefully you're doing this months before the breach. Maybe you're doing this in response to the breach, who knows? And this is what engineers will bring to you. They'll say, oh, we have a gateway. Our gateway goes to a load balancer, and here's our databases. And it's very pretty and very professional. But to a security engineer, it doesn't mean anything. Like, you can't do security against this. And we have I'm not yeah. Oh, and can you click it? Oh, if you go back into the
Previous slide.
if you open it into a presentation mode, it might be clickable. Tech is hard. And we could it's actually a different okay, can you open up the slide into presentation mode? I totally know how to do computers also. So oh, it worked in dev. Yes. Coming from the US, someone might have forgot their power is no.
No, try again. Okay.
Oh.
It's trying to open the PDF.
Okay. Oh, it's security. It's fine.
Oh, okay. Is that the one?
Yes.
Awesome.
So I don't know how many of you. Yeah. How many of you have done run books with your engineers or done intake? Nice. Okay. Awesome. And so this is kind of an example. I time box everything I do in security. I try to get it to an hour or a half hour. If I'm going to do intake with engineers, this is, I did this entire intake with one of my engineers in less than an hour. So some key information, what's the name, what's the system, maybe there's a code name, a version, edited, just high level documentation. Who is this impacting? Infrastructure, users, ML, product, data engineering, priority is medium, executive summary. And this is just kind of like, what is your system? You can give this to another security engineer, and in 5 minutes, they can come up to speed on it. What is exposure? This is gonna touch user data. This has publicly exposed endpoints, just some basic documentation. This is really what helps in a breach. Who are your key stakeholders? Who are the points of contact? And really, as a security engineer, as a living document, every time there's a design review, maybe you're doing requesting changes to the project or security approvals, you can keep all of your links in here, and I recommend doubly linking everything. So when you have all of your security approvals link to this document links to your security approvals, this document links to your design reviews. And so everything can be, you can pull up this document, go to all of those, and all of your artifacts, all of your, what is the GitHub link, system documentation. And this is kind of just, I don't spend any more than half an hour with my engineers the first pass. I try to make security easy. We just fill this out. It doesn't have to be complete. I tell my engineers specifically, do not fill this out incomplete. I mean, don't fill this out fully. Time box it at half an hour, fill in what you can, send it to me, we'll do a meeting. This is a living document that's going to live for the entire life of the product. When you have pen testing reports, add them here. When you get sign-offs and approvals. This is an intake form that lives through the entire life cycle. And when you have that breach, you can pull this up and jump straight into it. You can know who to contact. You can pull up all the security reviews. When they say someone's going to be fired for approving this, you have who approved this. And, you know, and it's documented and recorded. And so when this does actually get breached, you have this SDLC, and you bake security into each stage of the SDLC. But this is really what the SDLC looks like. It is madness. It is multiple teams, stakeholders, and you're trying to play catch up constantly, but you're trying to stay ahead of. And thanks to AI for helping me generate these amazing SDLC images. And so this is what we're facing as security engineers. And that's what I'm here to help with, is show that You talk to your team, you get your architecture review, you bake it in security into every stage of your SDLC, you keep documentation, you document what has happened in this breach, and then we do secure by design. And this is the, okay, this is where it's gonna get real kind of special. So how many of you use draw.io? Wow. Oh my. Okay. Ooh. Okay. So this is what your engineers walk in with. They're like, okay, we have our databases, and this is, maybe this isn't even, they don't draw this out, they just whiteboard it with you, or they just explain it and you whiteboard it, but you time box this at half an hour, and you go back and you turn it into something like this, where you have a load balancer coming in, you have your user section, the user database, some of the user functions, and then it comes off to your backend, and you start kind of pulling it apart and decomposing it into something useful to security. And you do this with your engineers in another meeting. Or you do this and you present it to your engineers for, now this is how I'm looking at your system. And again, half an hour, maybe it's a week later, and you say, okay, I've reviewed your system. We need to talk about input sanitization. We need to talk about authentication. Here, we're going to start talking to the engineer, and really the secret sauce is you're saying this is a red system or a critical system because this has user PII. And that is more important than all the security controls up front. And what you're going for is getting a common language and agreement from your engineers that this is PII, this is red data, because at this point they can say, actually, no, it's not sensitive data, and here's why. And you can have that discussion. And you really need to get the buy-in from the engineers at each change in this system, and this system architecture reflects another part of the system and more PII, and it goes to a data lake. And in the data lake, you have prod data and AI analytics, and you start pulling apart what the system really is. The engineers say, we don't have any bandwidth to do input sanitization or authentication. And you say, okay, I'm going to pull them off out of the design, and this is their agreement for how the system should be designed and what the design of the system is. And if your engineers say no, your security, you can advocate for it. They can say no, and you can do a risk acceptance and say, okay, we could take this to management that we're not going to do input sanitization. Or you can go to QA and help them understand how to do attacks that would leverage input attacks. But you start filling out the system, you start finding KMS keys, you start identifying more parts of the system. And by the end of it, you're starting to build out a more complete understanding of the system. And just to give a little bit of a flavor of, this is kind of how I represent a security boundary. This is input sanitization. This is the internet. This is what we're defending against. This is DOS level protection. Maybe this goes to Q4 next year, which means never. But we start identifying our business logic defenses. So maybe we're going to look at, it's a fintech and we're not going to take negative numbers on money. Or when we have logging and detection of user activity and data access, we're going to do it here. And you can start kind of slicing out, so red for scary, orange for problem, green for I should never get attacked here. And we have different types of security at each level. Typically red is more about defense and stopping. Orange and green are more about defensive boundaries and logging and detection. So on our guts, we mainly do logging and detection. On our outside, we typically do more of a hard shell. And this is where you kind of communicate to yourself, your engineers, other security engineers. I wouldn't show them all of these. It would more be for my internal team of identify these types of attacks. And remember when we talked about this is user data, this is red, those many meetings ago, this is where we start coming into the PII breach happened here. And so, or maybe you're just a security engineer looking at this and you're like, none of this system matters except for the PII. This is what I care about. And so how do you go about defending that one point? Is pretty much what our job is. We say input sanitization, sure, we're not doing it. DDoS detection, yeah, you know, I'll try to come back to input sanitization. We're going to just accept DDoSes, but this PII, that's what I care about. Everything else can go by the wayside. And so here's a design idea as opposed to a security control. We're going to make it write only. We're going to split the PII away from the rest of the system. And we're going to say, okay, we're going to alleviate this system of having PII. We're going to move it out. We're going to segment its logic. We're going to make it write only, so there is no read capability. We can lock this down with whatever compensating controls to make sure, even if this gets compromised, like someone can put bad code here in GitHub somehow magically, it literally doesn't have the access to read the database. It could corrupt it. It could do all sorts of other things. And this is where we can start building defensive layers, not with security controls, but merely with design changes. And this is where your engineers come in critical, is they need to agree to this design change. You as security, you're not going to come and split apart the code base and change the functionality and maintain this going forward. And so in the weird way, all these other security controls of the WAF, the input sanitization, maybe even KMS keys and the rest of the system, this design change is what protects your PII. And you can horse trade. You can barter the other security controls of, I'm not going to make you do DDoS mitigation. We can push that off to Q4 next year, never. But we're going to focus all of our engineering effort and get this out within 2 months. We're going to get this segmented and split and tested, and we're going to prioritize this. And you can start saying, I'm not going to make you install Cloudflare, a WAF, input sanitization. I'm going to still need authentication. We're going to need this, but we're going to prioritize the splitting off of the PII into another area. And then you find that on the back end, there's AIs and dragons, and there's unknown threats lingering out there. And where is the going back to the talk? Yeah. Okay, and then slideshow, current slide, look at that. Thank you. Tech is hard. And so you go through the design review, hopefully not when this is breached, hopefully months beforehand. And this is how you tackle engineers coming in with some random architecture. You actually split it apart, you pull it into its subsections, you start working with your engineers to get a common language. And what's most interesting is when you actually work through this with your engineering team and you take this to operations and you show it to them, they're going to say, that's not actually how the system works. It's actually deployed or built in another way. And there's Kubernetes containers. And then you start laying out your architecture, incorporating the Kubernetes containers. And when you talk to multiple teams, you'll actually come to multiple understandings of what reality is. You put it in that one design doc, and now everyone has to start agreeing on a common reality. So it's actually a really powerful way to get multiple teams to understand their own system, because nobody does architecture for their systems. I mean, does anyone in here have your developers actively maintaining architecture diagrams? Awesome. 3. Like, in real world, I would love to see all the engineers have actively maintained architecture diagrams for every system, but I've been an engineer, I've been developing software systems, and it's like, well, it's documented code, it's in GitHub, you know, like, and, but every one of those security controls that I showed you in these previous slides, every security control has to have an owner. We have Cloudflare. Who owns it? Not the developers. It's either operations or security. The input sanitization. Who owns it? Developers and security. Now this needs to have pen tests. This needs to have validation. This needs to have regression checking. This is now something that will forever cost the security team and the company engineering resources, and you can only have so many of these. But the nice thing is the designs. The design of splitting off the write only doesn't necessarily have to have an owner. That's just an engineering feature of the system. And that's one of the most interesting things is you have security controls, metrics, monitoring, pen testing, validation. On defenses. On designs, you just have features and functionality that's inherent in the system. And from a security perspective, how much effort do you have to put in that the system is segmented? You need to maybe check on the write only. You need to make sure that there's a separate VPC. Well, you can do that once every 6 months, and you can support a large number of designs. Whereas how many security controls, your team is probably 1 to 4 people of security engineers. You're lucky if you have 4 security engineers. And how many security controls, let's say you have 50 types of input sanitization all over your system, and you have 10 WAFs, and you have 100 endpoints, and they're all secured with bespoke, unique security controls, and a security engineer has to be responsible for them. As a security engineer, how many can you manage, maintain, do your day job, and make any progress? And so that's where, if you can break down defenses and the design choices, it's really powerful to try to design systems that are just secure. And so that's one of the real superpowers, because you can have thousands of designs, whereas defenses, you might only get a few. And so when you do recommend a security control, you're going to have a WAF. You want to have as few as possible, and maybe you have no more than 10, maybe 20 security controls that your team can actually support in an ongoing way. When you talk about designs, you get in there and you work every single sprint, you work every time a new system is designed to try to get as many security designs to make the system strong and capable. Yeah.
API gateway. I said we have previous PPT, like we can protect API gateway through the VM. So like how we can protect the KMS.
Question, how to protect the KMS? Sorry.
No. Yeah. Okay. So let's say your data is protected in a database and you have KMS keys protecting your database. For the write-only functionality, you can set. I'm from the AWS world, so I apologize. You can set your KMS keys to encrypt only. And so you can have Lambdas or EC2s or different systems have access to a KMS key, but in encrypt only mode. So they literally can't call decrypt on that key. And it's enforced by the KMS system, and it's enforced by an IAM policy. And then that IAM policy, you can set that to anytime a IAM policy needs to be modified, then it needs to be put through the security review. And you can even set your PRs to literally have one of the security team do the PR review for any changes that impact that IAM system. And so any more questions? Okay. How to secure your DNS systems. No, but it's a good one. And ironically, I come from over in the crypto world, and we've been destroyed by having our DNS hijacked. I asked my friends about securing their DNS, and it was DNSSEC and another recommendation. I have it up on a Twitter account of best practices for securing your DNS. But and as an OWASPer, I really do want a cheat sheet on securing DNS. Like that would come in very handy for me. And does that answer your question? Or I'm happy to talk about encryption in any way or scale. Okay. Okay. So you're looking at your security budget, and your budget as in resourcing and energy power of your security engineers. And this is where burnout comes in. If you have responsibility for your day job, your security reviews, maintaining your relationships with your teams, and security controls, and pen testing those security controls, that's where you come into burnout. And so if you have development and you have good practice and you have a culture that supports designing security into the process, and then if you do have a security control that you need to require, you push that. If you have a security control that you need to do a risk acceptance for, and you're going to escalate that up to the team, and I recommend that you review all of your risk acceptances at least once a year and keep track of every single exposure to the internet, to your partners, and make a policy and procedure every time we're going to make a new connection to the internet. You're going to have to get your CISO to sign off on it, because your CISO not knowing about a zero trust boundary that's now exposed to the internet, your CISO not knowing that you're having a new partner API gateway come into your guts, completely changes your threat landscape. And this is where you start enforcing good culture and best practices and the design reviews, and you start making choke points that are not security controls, they're just best practices. And it's like, sure, send it to the CISO. The CISO says, I acknowledge I got this. They can come and block it next week, but they at least were notified and can have a chance to block it. You try to not make a blocking process that security is a blocker until they're notified. Security just must be notified, and security can do what they want. But your real goal is to build trust with your team, and you're trying to get every SDLC process to have security. So when you're designing your product, when you're going out and scoping, building a new authentication system as security, you're advocating for 2 months instead of 1 month to build authentication, because you're going to need to do pen testing. You're going to need to do extra reviews, and your engineers are going to be genuinely surprised that it's going to take 2 months. And if at the early stages you can say this is going to take 2 months, your engineers can plan 2 months. And that's how you build trust and relationships with your teams. That's the end of the talk. That is a speed run. I'm happy to go in depth, and there's a longer talk from AppSec USA coming out relatively soon. Thank you.